using SCULPT on the 3D software CATIA by Gopinath Reddy. So I hand over the stage to Gopinath to take it forward.
Yeah, hi, hello all. I'm Gopinath Reddy, third year mechanical engineering. So I'm also part of IET NITK. I'm an executive member. So today I'll be taking CATIA V5 version V5 as a workshop for you guys through our event called SCULPT. So since most of you are beginners, my aim today is to familiarize you with CATIA and to tell you what it is and what it does and show some models to you guys. So that will be it. I won't be teaching you all the features and all the modules here because it's not practical for a person to teach everything, and also it's not easy to learn like in one single day. It takes a lot of time to learn complete CATIA. So here we'll be focusing on some important modules and some important features that we'll be seeing, and we'll go into each module and we'll model one particular object, and we'll see what type of objects are formed in the particular model, and so we can relate it to real life products. So starting off, firstly, before going ahead and start working on actual software, we'll just get to know some of the important facts and features of CATIA. So basically, you would have got this uh, like you would have had this confusion. Why is it named CATIA? Like AutoCAD has its definition. So all the software which has a particular name has some background to it. So here CATIA, it's an acronym for Computer Aided Three-Dimensional Interactive Application. So basically, it is an integrated computer aided engineering tool, which means nothing but integrating leading edge emerging computers and information technologies together for coming out with an innovative solution for engineering problems. So, and also to tell, okay, it was developed by Dassault Systems. You would have heard about Dassault Systems. It's basically a French company which is involved in aviation sector. So it was developed in 1982. It is that old. And coming on to what type of what type of engineering solutions that you can do in CATIA, you can actually most of the people have this confusion or what you tell think that this CATIA is only used for modeling, but it's not only for modeling. It is used for modeling analysis as well as manufacturing to manufacturing as well. So it's an integrated software, CAD CAM CAE integrated software. So I'll be explaining what the difference between CAD CAM and CAE in next slide. So CAD is basically it's the use of a computer to assist in creation, modification, and optimization of a particular design. See, it's basically a building block of any model. So all this sketching, part designing, all this coming to computer-aided designing, assembly stuff and all. Now coming on to computer-aided manufacturing, computer-aided designing, engineering. So once you've done your designing, like once you've modeled it, after modeling it, you'll have to know, like particular, say for example, you want to use that particular design model in one particular situation. You have to you have to have an idea whether that particular it'll work in that particular situation or not. Say for example, take a cycle. You take a chassis of that cycle. You have to be sure that that particular chassis of the vehicle can withhold all the weight of the person who's sitting on it, weight of the wheels, the person who's sitting on it. So we'll do certain analysis like stress analysis, strain analysis and all, and we'll figure out whether it will be withstanding that particular weight or not. So to do that, that is called computer aided engineering. That is where computer aided engineering come into play. Now coming on to computer aided manufacturing, once analysis is done and you figure out that it's going to withhold it, now the main issue is to manufacture it. So to manufacture it, you can't directly once an analysis is done, you can't directly go and manufacture it. You'll have to make a do a dry run, or you can't directly do a dry run because there'll be so many safety concerns and manufacturing concerns like wastages and all. So to overcome that, there are certain softwares that are created so it's to check whether the wastage is minimum and safety is safety standards are followed, all those stuff. So to 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 do those stuff, we use this computer aided manufacturing softwares. So CATIA can do that as well. So next, so coming to modules and workbenches that are available in CATIA, there are numerous workbenches and modules that are available. but we are not going to learn each and every one of them because there are too many of them. It's not practical for a person to learn everything. So the main features, like once you get into CATIA and if you are working in that particular field, you can once you get a problem, once you get an engineering problem, you can actually go and do it, like work on it yourself and get to learn each and everything in it. But then if you want to just learn more CATIA and keep it by yourself, and you want to show it to someone, okay, that you know CATIA, firstly you'll have to learn all these basic. These are the six important basic workbenches and modules that are available in CATIA. These are sketcher, part design. Sketcher is basically where you sketch, that is the building block of a design. And part design where you model actually from a sketch. And then sheet metal is where you sheet metals basically are formed like to make plates and all those stuff. Wireframe and surface design for surface modeling. And assembly where you assemble all the parts that you're made into one single unit. And drafting basically to actually see before this drafting is where it comes into play when you're manufacturing it. Because see, I want to tell you a production flow in any industry or company, because that's really important to understand where CATIA plays an important role. So any company starts off its production when it comes when it gets an order from customer. Once the once the company gets the order from the customer, the marketing department takes the order and it gives it to planning department. Planning department with R&D consults, they both together consult each other and check whether it is feasible to produce this particular product or not. After checking the feasibility, they'll give a nod, and they'll make a plan, and they'll give designs to the production department. Production department basically produce all these models and assemblies, and they'll join it together, integrate it, and they'll give it to marketing department, and they'll sell it back. So that is how the flow will be. So this CATIA software is basically used in R&D department. They will basically design all those stuff, like to check the feasibility, to design everything before going into production. So drafting, see, this drafting is used because see, an R&D person will understand how to model, what are the things that he has modeled, and what are the things that he has to do. But the normal person who is in shop shop floor, workshop floor, will not understand how to do it. So so basically, what these R&D people will do, they'll draft the design and they'll give it to production department. That is basically drawings. I think drafting is nothing but drawings. So they'll give the drawings to the production department. They'll study this. This production department will study the drafts, and they'll produce the products. So that's about the things that you have to learn before getting into software. So now we'll get into the software and learn actual stuff. So once you get into CATIA, CATIA, this is how the interface will look. So this is so before telling you, taking you into the modules, I'll just tell you what these things represent. First, I'll take you into Sketcher so that you'll get some idea. So here you can see in mechanical design, you can see so many modules. Again, under shape, you'll have so many modules, analysis and simulations. So it's practically impossible for us to learn everything. So we'll have to focus on some important modules that'll be used in daily life. Now, now we'll go into Sketcher. This is the basic building block of any model. You can't build anything without Sketcher. Now, yeah, let it be demo. Put as demo. Now here, so this is the basic interface of CATIA Sketcher. Now, so this particular thing you see was like the topmost thing which you see here. It's called a menu bar. You see like all the features that are shown beside these things below, side, all these features will be here. Not necessarily all, like most of the features will be here. You can find it here in the insert. You can find yeah, sketch based feature, pad and all. Here also you will find all those options. So once I click on the plane, I got into Sketcher. So this is the Sketcher interface. I think okay, this grid lines are off. So this is how it looks when you enter into it. If you want to off the grid lines, you can off it. That's your wish. Now, so the rightmost corner, whatever you see over here, it's called application toolbar. Like all the features related to what you're doing will be shown here. So if you want to do any sketching operations like drawing a rectangle, all those operations will be shown here. And then the one which you see at the bottom left corner, it's called a file toolbar. All the options that are related to save, all the options that are related to file or yes are here. Like the save option, print option, all these all are available. That's called, it's called a file toolbar. And the one that you see at the rightmost bottom corner, it's called view toolbar, because all the options that are related to view, like which angle you want to see, all those things are available here. That's why it's called a view toolbar. We'll close this. Go into Sketcher. So here, one more thing I forgot to tell you. Here, this is called current application. When you click on it, you can see which application you're working on. Like whether if you're working in Sketcher, it'll show you a Sketcher. If you're working in Part Design, it'll show you as Part Design. All this. Then so this is a Sketcher. I'll show you some features in Sketcher. We'll not go through all these options, because you can see here there's so many features. Here, solve this. Constraint options, there's so many options. Again, under circle, there's too many circles. Again, conic, there's so many conics. So it's better, we'll see some features and we'll go on see other modules as well, so that you'll get a complete picture of what CATIA is. So just drawing randomly. So once you get out of it, so you can see the sketch. If sketch is visible outside the sketcher as well. Now, once you come out of Sketcher, you can actually model here, because since we are just into Sketcher, will not be able to model it here. So this is basic sketch here. There are other options as well. I'll show them also. There are options like profile we just saw. Like all the drawing parts are called profiles, and operations like chamfer, the chamfer, all this. So this is the basic like whatever things that you have learned in AutoCAD, sketching features, all those things would be here. It's nothing special here. Like there are some features which are like different, and the icons are also different. But then overall picture, if you see the overall picture, it's the same. Now we'll go into part design module. So that's where the actual modeling happens. Part design. Now I'll draw some sketch randomly. Go out. If you want to give dimensions, you can give it as well. Give a dimension. Give a dimension of 100. Here as well 100. So I want to make a cube of 100. Okay. Okay, this is great. Yeah. Oh, just a second. I don't know what. Okay, there's some issue with the software. I'll close it and open it again. 1 second. go into Sketcher, we'll draw some random sketch and we'll model it now. So I use the option called pad. It is usually used to uh, make it a 3D object from a sketch. Okay. So if I want to reverse this backward, I can reverse it. Or else if I want to mirror extend, that is twice on both sides. I'll just do it so you can see the solid object being formed. That's about the modeling. Okay. Now there are numerous options again here. See, there's multi-pad. If you don't want to model it, like for example, there are numerous sketches, and you want each of the sketch to extrude to different level. I mean, 1 to 100, 1 to 20, 1 to 80. So then you use multi-pad option. Again, there's variable pad option, which is to actually like give it an angle, not extruding straightly, at 90 degree. You can give it some angle and you can extrude it that way. And there is an option called pocket. I'll just show you what pocket is. It's basically used to make a hole in an object. So I'll do this. The option called pocket. Yeah, here you can see made a pocket in the solid object that you made initially. So similarly, there are numerous options called revolve. If you want to make any round object like a wheel and all, you'll have to use this option called revolve. And cut, like in a revolve, if you want to make a cut in a revolve, then you use an option called groove. Again, a hole is different from a pocket because uh, in hole you'll only make us like it's basically used to make small cuts. Here in the pocket, it's usually made for big cuts. And rib and only circular here hole. And rib is basically to give support to any particular, like if there is an L kind of a joint, if you want to give any support, you'll rib, or else no, 1 second, I'll show you what rib is. So basically, a rib is nothing but you have like if you want to make a different sized object, so for example, one circle of 10 mm, another circle of 30 mm, and if you want to extrude it in a particular profile, like you go give one particular direction to it, and if you want to extrude it, then you can use the option called rib. Similarly, you can cut it like that only using this option called slot. So similarly, there are many options like this in part design as well. So this is about the part design thing, a module, and we'll go into assembly design. Once you're done with your part designing, you have to go into assembly designing. You'll to assemble all the parts that you made. Now I've already designed some parts and I've saved it in my PC. I'll just take it out and I'll just assemble them. So, I'm basically assembling rack and a pinion. Sorry, not into assembly. Okay, I'll have to use this option. Now rack open. I'm going to arrange them properly. Okay. So this is basically arranging them in a proper order, assembly. I think it's done. Yeah. One more P. So this is assembled. So these three parts are were made differently and they were assembled here in the assembly. So this is what you do in assembly. So there are other numerous features as well. You can go through it. So after assembling this, now we'll go into KMU kinematics, where simulations happens. How to generate like simulate particular design. So that you'll have to go into the KMU kinematics. So since this is a rack and pinion mechanism, there's already a rack and pinion mechanism that's already inbuilt in CATIA. So I'll use it. Prismatic mechanism. Prismatic joint. First prismatic joint is between the rack. Like this ratio. Right, prismatic. So this is basically to create mechanisms. See, there will be in your second year um, mechanical courses, you'll be learning various types of joints and mechanisms, like revolute joint, prismatic joint, and all those things you'll be learning. So using those things, you'll be basically designing using mechanisms. So I'll just try one more this thing. Like, there's some issue before.
Anyone with doubts, they can ask.
Yeah.
So, Gopinath, you can explain what you're trying to do right now.
Basically, I'm creating a revolute joint between this gear and gear and its gear support, and I have already created a prismatic joint between the rack support and the rack. So it's a 1 degree freedom, one single degree of freedom. These two joints are one single degree of freedom. So as soon as like when once the like this pinion rotates, the rack also rotates with it. So that's what I'm trying to do right now.
Okay. So, what sort of contact is there between rack and pinion?
A rack and like it's a rack and pinion joint actually. The joint itself, the name itself is called rack and pinion joint.
Okay. So, okay. Okay, great.
Almost done. 1 second.
Yeah. So we all are like really excited to see if how the joints work out. So I hope everyone else is also excited, whoever's there in the meet.
Yeah, now it can be. So you will get a message that once if you create a proper mechanism, you'll get a message saying that mechanism can be simulated. So once it is done, you'll have to go into the applications and mechanisms. Uh, so you'll see degree of freedom. So what you'll have to do is finally you'll have to end up putting degree of freedom equal to 0. There should be no movement until you should give it a movement. So
Hmm.
now you can generate it. See, I'll put in full this thing. Now you can see the mechanism working properly.
Hmm.
So this is what I was trying to do. So
Okay.
now this one I kept it as a like rack driven thing, which means when I drive the rack, the gear also should rotate with it. So
Yeah.
that's why. So you can do the opposite as well. There, like you can change the options as well. So this is about the DMA kinematics where you can do simulations. Now we'll go into the sheet metal, generative sheet metal design where you can do sheet metal. Like this particular module will be used like generally. If you take in simple terms, you can tell that you can make plates also in this. You can make like for example, if you take in large scale, you can produce sidewalls of metros and all, and sidewalls roofs and all, roofs of airplanes and all. You can do all those things in sheet metal. So
Yeah.
yeah, so here when you get into sheet metal, you'll have to actually make a you'll have to give the parameters. One is thickness, the other one is default bend radius, how much it can. Okay, those two. These are the like basic things that you'll have to go.
Okay.
Like
What was
generally,
the
if you see in
default bend
industry service,
radius?
sorry,
What was the default bend radius? What is that?
this default bend radius. I'll just show you 1 second.
Okay.
So basically, if you see any industry when they buy sheet metals, they won't get iron directly in an industry for production. They'll get sheet
Yeah.
metals. So they will use various operations like shearing, bending, laser cutting, plasma cutting, and all those operations, and they'll make it into particular sub-assemblies, and then they'll join those sub-assemblies to make assemblies, and those sub-assemblies will again be joined together to form like big assembly blocks. Those assembly blocks again they'll be integrated together to form final product. So that is how it works. So this sheet metal is really important thing in an industry. So in manufacturing process, this particular thing is used majorly.
Okay, and we can find this in the sheet metal option module, which is there in CATIA, right?
This can found here. So what I'm trying to do is right now I'm basically trying to make a plate right now, simple plate.
Okay.
You can see.
And how did you do that?
So there are numerous options again. Okay, like I'm not going into the details of all those options right now. So
Okay.
I'm just showing you what are things that you can do in each module. So
All
that's
right.
what I'm saying.
So I'm assuming you're gonna cut these shapes out.
Yeah, I'm trying to make a punch in it. So you'll just see in a second right now.
Okay.
Cut. Yeah, stamping. Okay, stamping options. I use this. So I'll just keep whatever the default is.
Hmm.
Okay. Be reduced. You can see.
Okay. This is an example of stamping, yeah?
Yeah, this is an example of stamping. So similarly, there are numerous options. I'll just tell you what those things are. Roll walls, like these are not so important. Roll walls and these things. When you have a different cross section, and if you want to make a sheet metal out of it, you'll have to use this roll wall and hopper options. Wall options are basic options. They're like wall on edge, once where you create another sheet metal on the existing metal. Then bending operations as well. There are so many options: conical bending, the type of bend, like based on which shape you want. Those type of bends are there. In cutting options, you have to like punching all those operations. Like you can do it here. Stamping and lowering and all. Like where one side cut will be there, the other side will be raised. So that is so those like there are numerous options. We can't go through them in one single day. It takes time for learning all those options.
Yeah, this looks like that mega mess plate that we get.
Yeah. That's right.
Yeah,
Okay,
yeah.
now we'll go into the surface module. I'll show you
All
what
right.
it look like. Mm, okay. Generate here it is shape. Under shape, we'll have a generative sheet design.
Okay, what does this do? This is for the shape modeling
Yeah,
surface.
not surface modeling. This is the most important module. Like basically, this has become famous because of this only. This generative shape wireframe and surface design. It's because see, generally when they started off this CATIA, like they had already modeling options, but then to model each and single like different things, it was really difficult. In Surface, it's really easy to blend. Basically, surfaces are easy to blend, so you can once you create a surface and you can like here you can convert
All
this particular surface into a particular like a model. So that will be really easy for us to produce.
Basically for like aerospace applications where you
Yeah,
need to generate
aerospace
lots
and
of.
automotive industries and all you'll be using this.
All right. Yeah, yeah. Yeah, we're
Yeah,
really excited to see how this works.
yeah.
So are you trying to fix the origin or something?
Yeah, I'm trying to make some random model, whatever comes to my mind right now. So I'm not trying to figure out like, oh, so I'm trying to make a, so I'm trying to show you both wireframe as well as surface model in one video itself. Now, what I'm
Okay.
trying to do is I'm trying to make a helix using
Uh,
wireframe. So yeah,
okay.
helix. Yeah, wireframe. We'll have helix.
Okay, so there's this option already available for helix.
Yeah, there's option available for helix. Now, for helix, you need a axis. So I'm doing axis right now.
Okay. So this is the axis of the helix.
Yeah, axis of the helix, and it lasts for a starting point. So this will be our starting point, and this will be our helix angle. Is sorry, axis.
Okay. Okay.
So this is my starting point. Axis is this. So you can see the
All right.
helix being formed. Reverse direction.
Hmm.
You can give the length as much as you want. Is it and pitch as well. And
Yeah,
increase it.
yeah. Hmm. So this is just a sketch, 3D sketch, right? We haven't modeled anything.
No, we haven't modeled as of now. I'll just I'll just make a surface that goes through this circular surface that goes through this.
All right.
Like,
Okay.
okay, I'll sketch whatever the surface shape I want it. If I want it rectangular, I can do it rectangular. Or else, if I need a circular one, I can do a circular one. So whichever shape you want, you can do it. Now, once I've done that, so I'll use the option called 1 second here. I'll go not visible properly over there. Extrude.
Okay. Extrude.
I mean, okay. Instead of extrude, because we are so extrude is basically just to extrude,
Yeah,
but then
yeah.
here we are using one particular thing, so we'll have to do other operations. So
Hmm.
here we'll have to use an option called
Sweep.
sweep.
Yeah,
Yeah.
yeah.
So here again in the sweep there are so many like some 40 different variations are there. You can you have to see it by yourself. It's not possible right now.
Okay. Okay.
Okay.
So
See
this is
you can see
wow.
the surface.
And this is hollow, by the way, right?
Yeah, it's hollow.
Okay.
If you want to close it, you can close it as well. I'll just show you how. There's an
Okay.
option called fill.
Hmm.
Uh, sorry here. Yeah, it's a option. So you'll have to.
Uh-huh. Do we need to select the surface? Okay.
You just have to select where you which all you want.
Okay, the edge.
Yeah, so it's closed.
Okay. Is it solid or is it just closed?
No, it's just closed. If you want to convert it to solid, you'll have to click it here. Like mine is cracked, so you can't do it here.
All right.
Generally, what you'll have to do to convert this into a solid is you'll have to click here. Then it will show option to get into part design. Once you go into part design, it'll automatically be converted into a part.
Oh, okay.
Yeah, that's about this thing, surface modeling. There are various so many options here. You can see this is the the biggest module in CATIA.
Uh, so this is another interesting thing, which a lot of people can do to start off with solid modeling in projects. You can have different cross section for the helical spring, and you can try applying the loads, and you can see, how it deforms,
Yeah.
enhances. So that will be a good project, and you can conclude if a circular cross section is better or a square cross section is better for all those
Yeah,
reasons. Start off with things.
yeah, that's right. That's right.
Yeah.
So I also show you how you can do CAM operation, like sorry, CA operation analysis in CATIA. So for that,
Okay.
I've already made a model. I'll just show you how analysis is done in CATIA.
All right.
So first, to do the analysis, you'll have to get into what model itself. I'll just open the model whichever I made. Open desktop. Cantilever beam. I'm trying to analyze stresses on cantilever beam.
Okay. So this is another added advantage with CATIA. You can simulate your models here itself.
Yeah, you can simulate here, but then it's you only use for basic simulations. You can't do like complicated simulations like you do in ANSYS or other software,
Yeah,
Abacus.
like a Baha rule cage will be really hard to simulate over here.
Yeah, that's
Yeah.
right. So this is just for basic simulation. If you don't want to actually learn new software for only doing small simulations, you can do it over here itself.
Okay. So one thing that I found out was like it's very relatable to SolidWorks as well.
Yeah,
Like this.
it's almost same. Like the updated version of CATIA is nothing like SolidWorks, but then there, like obviously the size of SolidWorks is really big. If you ask me personally, I'll prefer SolidWorks. But then if you know CATIA, you can learn, like you don't have to learn any other software. It's easy for you to find out because like SolidWorks is really user friendly. Once you know CATIA, you know what options are there. You can just find it or like find it there in the top, like in the many features. Yeah.
Yeah.
So
What
this
we
is
are trying to do right now.
so I'm trying to analyze this.
Okay.
So static analysis itself. Now, so I'll clamp it on one side since it is a cantilever beam.
Yeah.
So I've
Yeah.
already applied the material. The material that I've applied is aluminium.
Okay. Yeah.
Now, so here's this option called clamp.
Yeah.
I'll clamp it here once done. So I clamped it here. You can see the feature that is appeared.
Yeah. Yeah.
So before that, okay, here it's showing which type of this thing you need. Like what is the size of mesh you want.
Yeah. Mesh is very important before any
Yeah.
sort of FEM analysis or simulation that we go for. Yeah.
So basically, this is numerical calculation. Like any analysis we do is a numerical. Basically, engineering problems can be solved three ways: numerical way, analytical way, and theoretical way. So this is basically numerical way, experimental way as well. So this is basically a numerical way. What it does is basically breaking down bigger parts into smaller parts and finding out for each part and summing it together.
Yeah. That is the basic concept of finite element.
Analysis.
Yeah. Okay.
Yeah, 2.5. Okay, I gave the size of it. Now I'm going to apply force on one side.
Okay. So one side is clamped and the other side we're trying to apply some force.
Yeah, so I'll let it be like this. It's 10,000 newtons. Let's see what happens.
Okay. So we have created a model one side which is clamped and the other side we're applying 10,000 Newton force. And let's see how the simulation comes up.
Computing it.
Okay. So this is another interesting thing about CATIA. You can do these small simulations on the modeling software that you're using, which is, kind of an advantage. Yeah.
So it's computing right now. It gives us a result. Now, if you want to see the deformations, there's an option called deformation. You can see the deformations. You can see the stresses as well. One myself stresses.
Oh yeah.
basically for ductile material.
Yeah, that's come really beautifully.
So the maximum stress is 4.8 into 10 to the power of 8. So
Hmm.
minimum is 5.4 into 10 to the power of 6.
Hmm.
So this also you can see, and you also have like what is the maximum displacement. So here obviously there'll be maximum displacement, it's 20.1.
Hmm.
So that also will be shown here.
Oh, great.
So this is how you do simulation, like analysis in CATIA. So
Yeah.
that's about it. So that comes that we also have cam operations. Here you can see here in digital manufacturing and machining and all, you'll do cam operations here in the prismatic and lathe machine
Okay.
operation. But then
Hmm.
right now I'm not showing you because of time constraints. So
Yeah.
you can see it for yourself right now. So that's that. Okay, that takes us to the end of the session right now. If you have any questions, you can ask me.
Yeah. Okay. So anyone can ask, start asking any questions. Basically, this whole uh, session was to give a glimpse to everyone who's new to this technology and this way of mechanical design and the way simulations are done, and everything has gone to computer aided systems, which is again a course in, like mostly it's second year, fourth semester course where you go for computer aided engineering, where you are taught all this. So having a basic idea of this really helps and goes a long way to understand the basics of mechanical engineering. So anyone with any sort of doubts, obviously the session was just a glimpse, but if you have any doubts regarding the sort of research that you can get into, another
Yeah,
beautiful
so I
model.
want to show you. See, whatever we have done right until now, they're like very similar, very what do you tell, simple objects that we have created. Now you can see this tailstock assembly is basically an
Yeah,
assembly which you'll find in lathe machines. It's
yeah,
usually used to hold what do you tell, a workpiece tightly.
yeah.
So this contains almost more than 100 parts. You can see so
Mm,
many parts are there under this.
yeah, incredible.
So you'll have to make so first you have to learn like basic features. Then you'll come to know, like once you start working on it, you'll get an idea on how to work, and finally you'll end up doing really difficult things.
Yeah. So how long did it take for you to
Uh,
draw and
It
assemble?
it'll take 2 3 days. Like if you're continuously sitting for hours, or else it'll take you weeks.
Yeah, it definitely will. I tried modeling a car and it took me ages, honestly.
Mhm. Yeah,
So
right now we are doing a project in IET. It's called design of rice transplanter. Rice transplanter is basically a machine which will plant a seedling, like saplings, like rice saplings, in water, like in the soil properly at 90 degrees.
okay,
So
that's interesting. Yeah. So that would involve a lot of solid modeling, I guess. Yeah.
yeah, it involves so much analyzing as well. Like you use analyzing software like MATLAB and other stuff as well to implement, like combine together. They like we'll actually have to combine all the softwares and have to do it.
Yeah, that's an exciting thing that we're looking forward to in the coming expos. Hopefully, we'll see a great project from IT in that. And I think I have a question in the chat box. It says, how many semesters for my students will like have manual drawing, engineering drawing? Uh, so how many did we have, Gopinath?
Two, two,
First year included, yeah.
yeah, first year included engineering drawing.
Yeah. So basically, right now with the new curriculum, just to answer your question, Niranjan, it's yeah, you have to go through one compulsory manual engineering drawing, and then I think it's one semester of another manual engineering drawing, and then you go to CAD lab, fourth sem. Yeah, if I'm not wrong. Okay. So yeah, that was a great session, and we are really, the floor is open, guys. You can ask any sort of question. So okay, Samit has doubts. So how and where can we begin start learning CATIA and about the CAD software? So
Mm.
go for that.
Okay, there are numerous online sources in YouTube as well. Like you can just Google type, you can just type CATIA, like learn CATIA to like you type CATIA, you'll find out like many sources you can find out in YouTube. You can learn through them. So what like personally I'll prefer YouTube itself because like most of the things that if you want to learn, you'll have to pay. but YouTube is one platform where you can learn freely. But the thing is that if you learn from a like proper source, you'll have like a greater idea about it. But then YouTube basically gives just an idea on how to use this feature. It doesn't tell you, like for example, you want to design one particular object. It doesn't tell you how to do like how to do that. You'll have to use your own brain to do it. So like if you want to just learn features, it's better to go to YouTube and learn it.
Yeah, yeah, well said. I think it's true for Samit. It's true for all the technologies which are there. YouTube is a very beautiful platform where you can start off, and once you get into the subject, you'll have the basics with you, so you can take it forward and do better by yourself. So I learned a lot of things. I learned SolidWorks from YouTube. So yeah, it's all up to you how much you want to learn, and everything's there on the internet. And for any sort of guidance, anyone in this meet want any sort of guidance, Gopinath is here. I think his contact was shared, or you guys can contact us through the common groups. We'll be really happy to hear from you guys, even about the session. And if you guys have any doubts regarding how you want to start off, your life in mech or life in any sort of research work, these are the tools that you would really encounter, and make make the good use of it, of the mentors who are here, during this weekend. So I think this was the last session of a very eventful weekend for uh, IET Torsion, and we'll continue to bring these technical events. Though it's really hard to pull audiences because no one wants to study during their weekends. But anyways, if any questions you guys can ask, or yeah, one more question. Okay, so Gopinath, they're asking, don't we need license for these softwares? How do we get these access to?
Okay, there's the student version as well. You can use our NITK email ID and you can use it for free for some time. You won't be getting all the features, but then it's better than nothing.
Yeah. Okay. I think sure.
If you're smart enough, you can find other ways to download.
Okay. Okay. Another question, Niranjan. He wants to know where are the links shared for these meetings. So again, there's a bit of confusion, with this online setup. Usually, what we used to do is, spam and like go to the respective blogs and publicize it, and there'll be a seminar. But with this online shift, it's really hard to reach the people who are really in need of this. Because of the gap in communication. So usually it'll be there. Your CRs, if they're active enough to spam it from the groups to you guys, you will get it. Or else, on the induction groups, you will find the links for these events. And another way is to just register for these events, and we'll automatically add you. You needn't worry about joining it. We'll notify you. So that's how you guys can be a part of these events and keep learning and keep growing. Yeah. Okay. Thanks a lot, Samit, for your questions as well. And I think, yeah, it's another great event. We're concluding this, and I think Nitish would like to go ahead with the concluding remarks, and that's it.
Okay, guys, I think you enjoyed the event, and this one was the last one of our event. And further, there will be many more webinars and events on our club regarding this, such softwares we will be learning. And it will be, if you have any doubts, you can contact us, guys. Okay, so have a nice day.